morning, everybody. My name is Josh Schmidt. I'm with VHB. Many of you I've worked with over the years, either when I was on the contracting side or the vending side. I'm now on the consultant side, so as some would call it, the dark side, but it seems pretty bright from where I'm standing. So DOT asked me to put together a presentation based on ATC cabinets and kind of like what are the differences, what are the safety differences that take place between NEMA cabinets and ATC cabinets. And so we're gonna go over a few items. So we're gonna go over the shock potential between the two platforms, and then we're gonna talk about Maine DOT electrical service changes and the way DOT wants the services done. This is to help mitigate arc flash potential in the cabinets. And we're also gonna discuss generator transfer switch interface panels. I think standard spec calls for the generator interface panel. Is that right? Is Kurt here? Oh, there you go. You picked a good hiding spot. So I'm gonna pop this cabinet open, just in preparation. Can you guys hear okay with this mic? Or does it keep cutting in now? Okay. From my side, it seems like half the time I'm projecting and half the time I'm not.
You have to learn to be Taylor Swift.
Oh, okay. Okay, more like this? Oh, okay. Okay, so how many people in this room have opened up any kind of traffic cabinet? All right, most everybody, that's good. You're getting out into the field. It's summertime's coming, start getting a tan. So when you're walking into either a TS1 cabinet, TS2 cabinet, it's not that uncommon to find this. Now, this platform, this came from a TS1 cabinet I was at about a month ago. It's fairly typical for a cabinet that was installed like in the 80s. When you look at the exposed terminals in this cabinet, you can see there's plenty of, let's see, let's have a click, there we go. You'll see here in the middle, this is where your signal hookups typically take place, like the flash programming, red flash, yellow flash. And those are typically all 120 volt AC terminals. Up here, you'll likely have some 110 or 120, and then over here, back, for us that have been out there dealing with shelf mount loop amplifiers, if you weren't careful and didn't notice that there were terminals that had black, white, green, and yellow wires on it, you've got a lot of live terminals over here for your old shelf mount loop amplifiers. So in probably like early 2000s, we went to TS2 Type 1 for the Maine DOT standard. And even though this is a newer cabinet that was installed probably 10 years ago, same format. You've got live terminals that are exposed, and for the most part, we go into these cabinets, hundreds of times without incident, but there is always that shock potential. I know in my time working in these cabinets, every now and then you drop a screwdriver and you kind of do the, like, uh-oh, where might that land? But by most part, it's uneventful. Nothing bad happens. And I'll even say that when it comes to, now that I've worked on the NEMA cabinets, ATC cabinets, one of the benefits that I will say about these is that the terminals are all exposed. So if you're coming in and modifying that cabinet, for the most part, you find the terminal that's labeled for the input or the output that you want, or the voltages that you want, and you easily tie to it. But we have more than just electricians that get into these cabinets. So the DOT is looking to minimize shock potential. So we notice there's all kinds of open terminals here. I wanted to actually highlight, when you're looking at an ATC cabinet, there are still some potential shock points. the premise behind this is to make it as finger safe, touch safe as possible. But a lot of people may not realize that these input racks that live right here in the middle, in here, it's down here. I'm sorry, up here. Some of those racks will actually have 110 volts on the edge connectors. And the reason for that is so that like Opticom cards, preemption cards, certain auxiliary cards require 110 volts to operate. So just because you hear ATC cabinets all touch safe or low shock risk, I mean, I've seen people put stuff in here, like, you're working in it, you want to set your screwdriver, that's an awfully convenient place to set it. But you just have to be mindful that there could be live voltages there. Now, some cabinet input files are designed to only have 110 volts on specific slots, specifically for like preemption cards. I think the ones that you've worked with, Eric, like the Econolite Plus platform, they have specific slots where those cards go in, and so that limits the amount of shock hazard in there. Down here, you've got the service assembly. This is going to be pretty standard for all these ATC cabinets. They may not all look this way, but the premise is the same. This is where your electrical service comes in, and from there it distributes the power to the cabinet power supply and other auxiliary devices. So this is the front side. Here's the back side. Points of shock hazard in the back. And the idea was to make this so that the front of the cabinet, specifically the door where the controller lives and like engineers or non-electricians would be going into, was to make it as safe as possible. And then on the back side would be more of the live voltage side. So if you're looking at the back of the cabinet, you're gonna notice a bunch of field wires hooked up down here. These are for your signals. You may have auxiliary devices like this because you still need like external power supplies to run certain auxiliary devices. In this case, that power supply is running the RSU at this cabinet. But one major improvement that comes with this platform is that everything pretty much becomes plug and play. So you're not really hardwiring anything. You're not basically stripping out wires, putting fork terminals on them, and landing them on a terminal. By and large, most devices that are added to this have a cord and plug on it. And you'll also notice that this top one is almost fully populated, but they actually give you, in most cabinets, an auxiliary set. So you shouldn't run out of receptacles to plug devices into anytime soon. Same time, we were talking yesterday about the Phoenix connectors. So when we're talking about finger-safe connectors, we're talking about recessed terminals. So if you were to actually grab them with your hand, you're less likely to, as we say, touch the shiny parts, right, and get lifted. And to piggyback on what we were talking about yesterday, I do think that there's some improvement that could be made on these. And that's kind of on the manufacturer level, but as long as they're open to feedback from customers, I think there's a path forward to find a good connector that the field wires can be secured to without potential of loosening or creating loose connections that affect cabinet operations. So, I guess any questions on that? Yes.
Just having seen a couple of those, it's interesting you also don't have the auxiliary Christmas light outlet, and some of the angles and sharp edges of some of those components in there, and running the wire to get over to that external outlet, that is another potential.
Up here?
No,
Oh.
that's physically mounted on the outside.
Oh, so.
The Christmas light.
I wasn't sure what you meant by it. So the GFI that's mounted on the outside of the cabinet. Yeah, so on these cabinets, and this is in the state spec, you have a dedicated service receptacle that's on the outside of the cabinet. It should have a breaker. Typically it's 15 amp breaker with a GFI receptacle. So like when you're showing up and you're doing work, you're really not looking to plug drills or other like high current devices in here, because this is what's called a clean electrical bus. This is where electronic devices should be plugged into. So if you're gonna be running a hammer drill or something like that, there's a receptacle on the side of the cabinet for that use. But you're saying in terms of...
I've seen some of these run where, you know, you're hot into the ground, it's just free air through there, and with all the sharp edges that are...
Oh, the way the conductors are run through the inside of the cabinet?
Really ought to at least be in flex. Mm-hmm. Just to keep that...
I'd agree with that. You know, or at least like, so what Eric's talking about is loose conductors being run through the cabinet. And really, if we take a quick look over here, a lot of those loose conductors that Eric's talking about would be behind the service assembly. And it's not that easy to get to, but yes, if you've got to get down there and start reaching in there, Eric's saying, you know, some of the edges are sharp, so you have the potential to chafe those wires. I would agree that at least like some woven sleeve, something to keep it so that it can't have rub damage. Anyone else on that? No? Bless you. I'm just going to move on to changes in requirements for electrical services. So this, I've always felt that this was an interesting setup, because when I got into the industry in 2001, the way that the traffic cabinets were installed with the electrical service, this is pretty standard operating procedure. You know, the conduits coming from the service pole come up into the cabinet. It wasn't uncommon to have a service loop, say 15 feet coiled up. And then you're literally running the wires that are coming down from the utility, so like directly from the transformer that's up on the pole, is coming into your cabinet and running up the side and then into the back of your meter trim right here. So what you're dealing with is unfused utility power. So when we start talking arc flash potential, that's your most likely culprit for there to actually be an accident where you have a chafed wire or a wire gets pinched in the door. You're actually going to have a lot of potential energy coming from the transformer, because there's no service disconnect until it comes back out of the meter and down to the main breaker in the cabinet. And coming from a technician stance, I've stood up my fair share of cabinets I got hit. It's amazing what these cabinets will take. You know, when you have a car hit one of these cabinets and it boots it 10 feet off the foundation, but that service loop is long enough and the wires don't break, I mean, it's not uncommon for either the intersection to still be running, or you simply stand it back up. Nothing's that damaged. Maybe you replace a load switch or replace the controller if that took a hit. And it starts running again. But, so even though that is one of those benefits, you know, the safety hazards that come with having that unfused utility power is something that DOT wants to get rid of. So, in order to do that, what they would like to see, and I don't know, Kurt, I don't know if this is in the standard details or if we're planning on adding that. That is being updated? Okay. So to get around that arc flash potential, they want to start running the utility conduit on the outside of the cabinet. Now, there's been plenty of installations where there's still installations taking place, and it's not like it's a huge crime, but it's what we want to get away from. So we're still I'm still seeing some cabinets where they're bringing that conduit inside the cabinet foundation and they're sleeving it in liquid tight. So technically you are creating a barrier between that utility power and the inside of this enclosure. Whoops. and the inside of the enclosure, but the spirit of the policy is that they want to start seeing that run on the outside so that it doesn't enter the cabinet at all. Standard practice now, in fact, I think CMP enforces this, but the meter trims that you're using on traffic cabinets have to have a bypass lever. So if CMP or the utility company needs to service that, they can throw the bypass lever, pull the meter, and you don't lose power to the cabinet, because that would be a public safety issue. It's pretty standard for like commercial buildings as well. What this also allows us by doing this is that you can now have an externally mounted service disconnect. So what that does is that greatly reduces your arc flash potential because you now have an overcurrent device before anything even enters the cabinet. So the cabinet basically becomes a branch circuit in the electrical world. So you just are really minimizing that arc flash potential. It's pretty important though to keep in mind that the breaker that's put in here actually has higher short circuit characteristics. I don't know that and Ron, maybe you could highlight this. I mean, that's been my standard practice. And I don't know if you necessarily need it for that breaker to act as a service disconnect.
The breaker has to be bigger than the transformer feeding it. And every transformer, the impedance of the transformer basically gives you the short circuit current rating.
Okay.
KVA transformer is like, I think it's around 9,000 amps.
Okay.
Regular 10,000 amp breaker, ATC rating is good. You get up to around the 25 kVA transformer, now you're pushing that, right?
Mm-hmm.
There's actually CMP, there's a impedance table, gives you the max. And there's other factors, how long the service run is. But before any break is put in, you really should contact the power company and ask for the maximum short circuit current.
For the transform.
Size of that. If
Based
not,
upon the run.
the breaker may or
Okay.
may not open.
Okay.
You gotta do an arc fault cap before you size that, just to get there.
Okay. So I guess for me, this is a little bit unfamiliar territory. I'm not an electrical engineer, to start calculating arc fault current.
Yeah, because you've got the different AIC ratings, right? So 65, 22, we've got all the different ratings.
And it's based on service, right?
Yeah.
Basically, what the transformer can supply.
Okay, so I'll just ask an open question. So on a project, whose responsibility should that fall under?
Electrical contractor should notify, I mean, we get submittals all the time, 10 KAIC breakers.
Mhm.
How do we know? What are you looking
Right.
at? Are you looking into a grid in Portland?
Mhm.
Looking into a little 10 kVA can on the
Yep.
outside of, residential, basically transfer. So it should be, whoever's calling for the service, should get the short circuit current rating.
Okay.
And that's right.
Okay. So if, and this isn't, I'm looking for a shortcut for people, but
22 KIC is gonna take care of probably most of them, but to be sure,
yeah.
most of them are gonna be hooked to a 10 kVA transformer, which would be well.
Okay. So from what I'm hearing from the people that are smarter about this stuff than me, the 22 KAIC breaker is probably going to cover you in most cases. Due diligence should be done on it. So don't take this as, we should just put these in. Technically, you should be doing those calculations, contacting the utility company. But it sounds like this is at least a good faith effort to allow, provide more protection. And in most cases, when you're looking at the main breaker, 30 amps covers everything in this cabinet. If you're going to have lighting attached to this, there are some cases where there is intersection lighting that runs at 240. So you'll have to have considerations that this 2-position load center may not be enough, and you might have to expand to a 4 or a 6. But obviously, you just have to make sure it's rated to be service disconnect enclosure. So yeah, just to touch on what I said earlier, these cabinets are, I guess I'll say by and large, they're rated as NEMA enclosures, so they are an electrical enclosure. So the circuitry that resides inside of it pretty much are considered branch circuits. Still have a shock hazard that's present with them, but because we now have a service disconnect on the outside, you're not so much exposed to arc flash potential. Let's see. So yeah, there is. So in the service assembly down here, where your utility power comes in, you have removable surge protection and line filtering equipment in there to clean that power as it comes in. I know that we were talking yesterday about, dirty power or like unstable power. These typically do a pretty good job at cleaning that up, but I know we had a condition in Augusta where we had a funny power anomaly where most of Western Avenue went down to like 40 volts for like 10 seconds. So to me, and they didn't come back out of flash, right? So these cabinets are designed to lose power and then come back up out of flash without anyone having to go out there. But the best I could determine was that maintained 40 volts for 10 seconds, put the CMUs in a state of like hysteresis. So it really didn't power down and then power back up. It just kind of fell in this state of limbo. So it required someone to manually go out there and cycle power to the CMUs to get them to unlatch from that fault. I'll start speeding things up a little bit. But in general, when you're looking at how the power is wired in these cabinets, so you've got your meter trim on the side, your service disconnect here. I'm finding most contractors, they'll run those branch circuits down kind of along the skirting, either above the skirting or in this area, and then back up. So it's crucial to keep in mind that feed is coming through your manual transfer switch and then back out of it through the contacts in that transfer switch to the service assembly. So this is typically what you should see. Then obviously when you're on generator power, and I'll show you the sequence or the procedure for transferring it. But in this point, when you're on generator power, you're just feeding into the manual transfer switch to the service assembly. So I've been asked this. I've been asked this a couple times now. On the transfer switch that was used on this, it's a 4-wire transfer switch. So technically, it's a 240 volt transfer switch. These cabinets only run on 110 volts. Now, even though the transfer switch is rated for 30 amps and you have a 30 amp main breaker, typically these cabinets draw about 600 watts, if that. So there's two lines of thinking. If you're gonna put it on generator power, you can either use a small suitcase generator, an inverter type is preferred for a cleaner power out of it. And then you can use an adapter cord that takes that 110 standard plug off the generator and brings it to a 4-wire plug. And what that adapter cable does is it actually bridges the two hot legs together because you don't know which leg they necessarily wired to in the transfer switch. So it at least supplies power to both of them, and then you'll get it, you'll power the correct leg in the cabinet. The other option would be to bring out a larger generator that has a 240 volt 4-wire plug on it and just hook it up, and there's no, it's 1-for-1 at that point. So real quick, so if you show up and you're looking to transfer this, the utility power is out, you're the person that's coming out with a generator, hook it up. When you go in, these are locked. So by and large, the keys can be stored inside the cabinet, or if the town the town or agency, handles the security on who has the keys. So once you pop open that transfer switch, you're pretty much gonna pop the front cover open, and then underneath, it can be a little deceiving. There's an access cover that you have to flip down, and that will expose the generator plug, the twist lock plug. So when you connect it up, you just got to bear in mind you're going to have one terminal that looks different. That's your ground terminal. So it's keyed specifically, so you can't plug it in incorrectly. But it's really important that when you plug that in, you give it a quarter turn twist on it so that you lock it into place. Once you have that hooked up and you got your generator running, you just simply snap the lever from line to generator, and everything should start running just fine. And then once utility power is restored, you just snap it back into line, disconnect your equipment. Up here I put, in one fluid motion. We hear that term's used pretty universally. So it just simply means don't pause in the middle. Just when you go from one side to the other, just snap it in place. So, I don't know, any questions? Yeah.
So, I guess a couple questions. One, instead of having the added expense of your meter trim and then your disconnect, why aren't you just using meter disconnect?
A combination?
Yeah.
It's actually cheaper to have separate ones.
Okay. And secondly, I guess, from working in other states,
Mm-hmm.
why putting the meter on the outside of the cabinet like that versus a separate independent meter pedestal? Because as you got further on and you've got coming out of that back through the cabinet to get over your generator transfer switch,
Mhm.
I mean, that's just now more wire that's in that cabinet that's just there to be
Mm-hmm.
chafed, grabbed onto, that you just brought it in once.
So Eric brings up a good point, and I see other states doing this, a separate power pedestal. And I know that there was a time where, especially when highway lighting was connected to these services, that you would have a standalone pedestal meter, or meter pedestal, sorry. I can't answer why we necessarily went away from that.
I say it's because of damage, just something else.
Another phase, another piece of equipment out there.
Right.
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 Okay.
When we came up with this, on the cabinet, pretty universal. But if if you're gonna put a pedestal, then we concrete base that pedestal or drive it.
Okay.
There's something else in it. Somebody plowing off the side of the road, somebody sliding off the side of the road.
Yeah.
There goes that, there goes this. At least this holds up better than a 4x4 post in most cases. And you don't have to put it in much more than a 4x4 or 6x4.
Okay.
Separate service. So
I-
that's why we do it. And then even on our street lighting cabinets in Portland now, we're not doing them on our street light services.
Yep.
We're doing them on the small EPX enclosures. They're 18 by 18. They're about 6 feet high, 4 to 6 feet high.
Yeah.
High enough to get the meter on. The meter enclosure has to be 36 or 42, but, so we have metal cabinets there too, because they get hit by plow trucks, they get hit by cars. Those are more forgiving. I mean, they'll dent it, they may see it a little bit more than a 4x4 post or a 6x6, so.
Okay.
We've gone to that pretty much standardly for the city, so.
Okay. I know I've worked like exit 42, the power circuit simply
Well, that
came
was
out
the
of,
setup, and I think, having worked in Massachusetts, having worked
Mhm.
in New Hampshire, having worked in Vermont, I mean, nobody else, other than I think the city of Concord did this,
mm-hmm,
one or two other municipalities, nobody else does this. It's all a separate
yeah,
pedestal. And then, to your point, now it's all a branch circuit. And like I said, just where you're running all those extra wires to go over the generator panel, it's just, to me, that's just another potential point of exposure.
yeah, that could be.
So we'll just go down and just go back up from the everything has to come up from the bottom of the cabinet, so we can't just come in through the side. So if,
Okay.
like you had your disconnect, your meter, just have it come back down and then back up to the bottom, just so we can get as close as possible to that main circuit breaker,
Okay.
because so you minimize the extra wires. Yeah, just something.
I know Mass DOT, they'll actually put a cutout or a disconnect on the riser pole itself. I don't know if that's an option here. I mean, I would think that it could be an option to be able to have the disconnect. And what does make it kind of nice is that if the cabinet does get hit, they have a point where they can disconnect that feed before the utility company even gets there. But it's certainly food for thought.
Well, and Ron, this might be a you question, but shouldn't that vertical be steel?
Depends if it's subject to physical damage. Schedule 80.
Mm-hmm.
I mean, if it's Schedule 80 PVC and stuff, I'm not too concerned about that. Steel brings another level of problems, and Josh will probably talk about a little bit.
Well, it does. I'm just, there's the point that, these cabinets can take a lot of abuse, but that PVC conduit's not. So,
But Schedule 80 is, Schedule 80. And steel brings its own,
oh, I don't disagree. I'm just,
We do PVC coated RGS, so it's like, it's kind of the best of both worlds.
Oh, okay.
Yeah, adds a little price to it, but,
Mm-hmm.
But anything from the 3 feet up, anything above grade has to be required to be PVC coated RGS. So bridge light, anything above grade.
Oh, okay. Okay. I guess. What's that? Another question?
I was just gonna say, the times I've seen the meter separated are largely when the utility company owns the meter, but the municipality or the state owns the cabinet.
Okay.
So there's like this kind of disagreement of like having different owners on the same thing. I don't really see why it matters too much, but some folks do, I guess.
Oh, okay. I guess one last thing I'd like to bring up, and I know I'm over my time, but I'll keep this short. So yesterday, Ron when he was talking about conduits and when does conduit, by DOT policy, when does it have to be steel or concrete encased PVC? So when I was on the contractor side, we were dealing with this quite a bit, and I think for a long time there was kind of an unwritten rule. Well, there's always been a rule on the books that I am aware of that any electrical services that are in Maine DOT right-of-ways are supposed to adhere to that, either rigid steel or PVC encased in concrete. And when I was on the contractor side and we were trying to do this, it became very cumbersome because the PVC conduit, I think most people in here would agree that the PVC conduit's going to stand up over time. But the concrete encased protection was a major hurdle because on the project that I was on, where we were doing 100 of these, that concrete needed to be tested and QC'd like it was a mast arm foundation. And it basically became unaffordable to do it because you're not gonna get a concrete truck to show up to pour a quarter of a yard just for your electrical service. So in that spirit, I hit Ron up after his session yesterday because we had submitted, we had made the argument that shouldn't have to be tested. It's not structural in the sense of holding up mast arms. And so based on a conversation with him, he was saying that he would be agreeable as long as it was 2,900 PSI concrete, and as long as you have 4 inches of protection all the way around that conduit, then that would be feasible to be used so that you don't have that conduit rusting out in 30 years. The PVC by general and large would stay intact and be reusable, but you still want to protect it from excavators or any other signs.
I think we've all seen any steel, even galvanized steel conduit put in the ground for 30 years. You couldn't guarantee the integrity or continuity between the two ends. You know what I mean?
Mm-hmm.
PVC in 30 years will be PVC in 30 years.
Yeah.
I actually prefer it under the roads. I know the long thing, we had to sleeve everything. obviously, if it's service cable.
Okay. And I mean, the utility company is going to still dictate that you have a steel 90 at the base of the pole, and the first stick's going to be, going to be steel going up the pole. Got to remember to bond that, especially if you're transitioning to PVC, right? Because that could become energized, so that needs to be bonded.
Home Depot or Lowe's, you can, it says right on the side of the bag, factory,
Mm-hmm.
the compressive strength of it.
So.
I don't see that. You're not holding that, if you was holding up a mast down or something, no.
Yeah, absolutely. Absolutely. So I just wanted to point that out for, coming from the contractor side. It sounds like that's I think that's a reasonable way to get around this, that's affordable, and that's, that's not going to become a scheduling nightmare, because you're not going to get a state concrete truck there for a quarter of a yard. So, all right. Any other questions? All right. Well, thank you. What's that?